Hey, this is Mr. Beckstrom, and today we're going to be looking at question number 14. This is in section 2.5, and this is graphing a cubic function here using techniques through shifting, compressing, stretching, and or reflecting. So one of the first things we want to do is we want to look at a basic cubic function and see how that behaves. So we can do that looking at the graph here. So all I'm going to do is this is the cubic function there, and we're going to put it in, and that's it right there. So here is our basic cubic function. It goes through the point 0, 0. It goes, it starts off at negative infinity, goes up to 0, 0, and then kind of increases up to positive infinity. Now we want to make the changes, the shifting of that function there. And so when you add a 2, that's going to take it 2 to the left. So that's going to be a horizontal shift 2 to the left because it's a plus 2. You might think that, well, if you add 2, you should go 2 to the right. But in these cases, you're actually replacing the x with the x plus 2, which makes it go 2 to the left. But this does go, this is a plus 5, so that's going to be a vertical shift of 5 up. So you're just going to move that to 5. Now we're not going to reflect over the x or y axis because there's no negatives in front of our cubic term. And save that and check it, and that's all you're going to do for that one. So if inside the parentheses, if it's a positive, you move to the left that many units. If it's a negative, you move it to the right that many units. And outside of the parentheses, if it's a positive, you're going to move it up that many units, and if it's a negative, you're going to move it down that many units. All right. The next thing says, what's the domain of our function? Well, remember from previous problems that it's generally going to be negative infinity to positive infinity unless there's just some x value that we can't put in there. But here, there's no radicals. There's no ratios with a variable on the bottom in the denominator. So we can put in any x value that we want, and that means that you can just go from negative infinity to positive infinity, which I'm going to do right here. Negative infinity all the way to positive infinity. Remember, we use parentheses because we never actually include infinity. And then the range of it, that's the possible y values. Notice this thing goes down, and we have to look at the graph in order to evaluate that. With the domain, we can look at the function to see if there's any restrictions on our x's that we can put in there. But with the domain, we look at the graph, and we notice that it goes all the way down. Here's our y values. It goes all the way down to negative infinity and all the way up to positive infinity because it just keeps going up. So even if we were to, well, we can't zoom out any further. But this is just going to be the same thing. So negative infinity to positive infinity. And that's it. So if you have any questions, let me know. And have a great day. Thanks.